So, what is a higher order function? Kind of an intimidating name, higher order functions. Well, a higher order function is really just a function that takes one or more closure slash functions as a parameter and or returns a closure slash function. So all it has to do is take or return a closure because we know a function is just a named closure. So technically, we've already made one. Congratulations. Our example was a higher order function. It might be a bad example, but it's the concept, and that's what we're trying to focus on now, is not the most difficult version, but an understandable one. So let's look again at it. So we've got this type alias combines to strings, takes a string and an int, returns a string. So our uses string factory takes that closure, combines to strings. So it's a higher order function. It takes that, and we can pass in anything that matches that type, any type of closure. We were doing it with a function. We were also doing it with a variable or a constant named afunc of that same type, but it meets the definition. It takes a function. We could pass in a closure also. So we're already doing this. Now we just need to put it into practice and look at the provided higher order functions in Swift that when we use them, we really start realizing the power of Swift. And I think you'll agree that when you start using these, they apply in so many places, and it makes your code more efficient, more readable, and more maintainable. So let's get into the specific higher order functions. So now we're going to get our hands dirty a little bit in Xcode. So we start up Xcode, and I'm going to get started with a playground. I want to make sure it selects iOS and a blank playground. And I will give it the default name of my playground and create it. The first thing I'm going to do is delete the contents and stop it from running. Then I'm going to expand it to take the full screen. I don't want it to run without me selecting it, so I'll hold this button down, this arrow button in the bottom left, and select manually run. Now I can tell it when to run instead of it just running all the time. So I'm going to start with an array of names that we're going to sort. So I'll type on line 1 var names equals, and then I'm going to give it an array literal of Bear, Kyle, Jenna, and Andrew. And then I want to sort these names. So I'll call names.sort. There's no return type. And I will print the names. So there being no return type shows me that it should sort the actual same array. And there it is. When I print it out, they've been sorted. Well, another way to call that, instead of calling the .sort, I can comment that out and I can say names.sort and use this one that also doesn't have return type, but it has one parameter called by. Well, what type of sorting did this do? It did alphabetical sorting, sure, but what type? It did ascending. So if the first value was less than the second value, that's what this comparison is, this type of string returns bool. Well, that's the type actually of the less than operator. The less than operator is the same thing. And so if we look at a string, if I do Command Option click and go to the definition of a string, if we scroll down, we'll see eventually that there's a definition for less than and various other operators. If I search for less than, I'm going to find a lot of them. Now we're starting to see some of these operators. Plus, plus equals. Notice string returns string. Well, the less than returns a bool because it's a comparison. There it is. The less than is a function. Takes toString, return a bool. That's what we're passing into our comparison for this by. So if I run this, it should give me the same output as before. And it does. Those are the same things. Notice if I have an array of ints, 1, 4, 7, 19, 5. If I go to sort these, notice the type it takes is int returns bool. Well, that means I could pass in the same thing. I could pass in the less than operator. It matches that type. And again, they should be sorted by value, ascending. We'll run this one, and sure enough, it does. They were already pretty much in order, but the 5 wasn't, so that proves the point. So notice how we're passing in this function as the type. In this case, string returns bool, and for ints, it's int return bool. We're passing these in as a closure. This is a higher order function. Why? Because it takes a closure as the parameter. It just so happens that it also modifies the original version of the array. Well, let's keep looking because there's more to sort than just this. So we want to look at some more aspects of sorting. We're going to talk about sorted. So sorted is a little bit different. So I'm going to delete some of this code right here, and we're going to look at sorted. So I'll keep my names array, and I'm going to call names.sorted. Notice this has a return type. It's an array of strings. That's the same type as names. And you'll come to understand that that means it's going to return a sorted array of names. It won't change names at all. Notice the parameters, notice the return type. So in this case, we're going to say let sorted names equal names.sorted. Well, there's another interesting thing. Now that it knows I'm assigning it to something, when I go sort, there's a red line through the two that have no return type. It wants me to use one that has a return type. So I could use sorted, and just like before, it would do it with the default less than, so it would sort it in ascending order, and that's perfectly fine. We could print out sorted and names, and notice that the sorted ones are in order. The names have not changed. So I print out names, and the original version hasn't changed. That's perfectly fine. But we also notice that we've come to understand from the first couple of videos that we can pass in our own closure. So I can say let sorted names equal names.sorted, and I could have done this on sort as well. Notice it takes a string returns bool. So does sorted. It takes a string return bool. So I could pass in a function of that type. Do I have a function of that type? Yes. I have the less than. That's a function of that type. Do I have another function of that type? Maybe. Maybe I've written one, or maybe I could pass in a closure. I just want to get to the function. I'm not that interested in creating a class instance or using a struct or anything else. I just want to pass it in right here. So what I can do that makes it really easy is while this string returns bool is highlighted in blue, hit return. And it's going to flesh it out for me. And I can do the first parameter's name as value 1. The second parameter name is value 2. It already knew the return type is Boolean. So all I have to do is define something that returns a bool. Well, I could say return v1 less than v2. So what's that going to do? If I print out the sorted names now and run it, what's going to happen? Well, it sorted it just like it always did. That's no big deal. I could do the same thing with an array of ints, and that would work perfectly fine. I can pass in a closure, and it do all the work for me, or I could change this to another type of sorting if I want. Reverse it. Or what if I even wanted to sort them by the length? That's my sorting. Anything that returns bool is going to be fine. I just have to give it something that takes two strings and returns a bool. And now I'm dealing with higher order functions. This might be along the lines more of what you were expecting and some of the types of things you've seen and maybe didn't understand them. But now again, notice that this is a closure. It doesn't have a name, so it's not a function. It's a closure, two parameters, and a return type, this keyword in, and then the body, all surrounded by curly brackets. Easy peasy. We are on our way. So you're already well on your way at being a higher order function pro and a Swift wizard, and you're doing great. Now we're going to talk about the Foreach higher order function. Now we all know what for loops are, and we also have probably even seen for in. Depends on what you want to call it, but we're going to talk about the for each now. So we have our function names, and we're going to call for each. Now notice what it takes. It takes a closure that takes a string, returns void. So it doesn't return anything. It only does some operations, but has no return type. So what does it take? It takes a string and returns a void. It doesn't return anything. So it just does some operations, and it's done. It's called once for each item in the collection, in our case, for names. We can do whatever we want to it, and then it's done, just like a for each loop. So I'm going to hit return on this one, and notice the blue section is highlighted for the closure, and I'm going to just hit return. And for each of these, it takes a value. Now, my temptation is to say name because it's in names, but I always tend to then in the body also use that same, and then I type names by accident or autocomplete. So instead, I'm going to call this val1 just to be a little bit cautious. And in here, I'm just going to print val1. And when I run this, it's just going to print each value from there. That's fine. Maybe I have an array of objects and I want to save them to the database or send them to the server. Who knows? But for each one, it's going to be called, and I can do whatever operation I need to. This is a very simple example. Let's also look at how we can do a for each on the enumeration of an array. So we can say names.enumerated.foreach. Now notice what this takes. It takes one type and returns a void, so it still doesn't return anything, but look at the type. It's in parentheses, and there's names, offset, and element. This is a tuple. Now, if you don't know what a tuple is, it's not a big deal. It's just multiple, otherwise unrelated values put together in one thing. It could be 2, 3, multiple values. I tend to try to stick to 2, maybe 3. After that, it gets a little complicated. But don't overthink it. It's just 2 values in parentheses. You can access them by index of 0, 1, 2, 3, 4. Or if they're named, like in this case, you can access them by the name, offset, and element. So we'll look at that. I'm just going to hit return. And again, I'm going to let autocomplete and Xcode do the work for me. And I'll hit return here and give the parameter a name. In this case, I'm going to call this tup for tuple. And then I'm just going to print out the information that I'm going to access from the tuple. So I'll print tup dot, and I have the element, and I have tup dot offset. So I'm going to add that and use some string interpolation and type tup dot offset. So that's the element, that's the value, and that's the offset. That's where it is in the array. So it prints out the names from the for each, and then the names and offset from the enumerated for each. So there's different uses for this. I'll let you come up with that based on your requirements of your function. It's just another way to cycle through your arrays. You can also decompose a tuple by saying let val, and we'll just call this num equal tup. This is decomposing the tuple. And now I could print those two, val and num. So it took those tuples values and put them in these two constants. Oh, I have these backwards. So this is num and this is val. Val needs to be the string. I can also decompose them right here. So I can delete this line and run it. Oops, I have duplicate parentheses. And now it's doing the exact same thing again. I've just decomposed the tuple here. I can decompose it later, or I can access them through the dot notation. But either way, I'm cycling through using the for each higher order function. I feel powerful here.